Alright everyone, so welcome back to another update on my game engine, and it's the first time I'm using the camera with the NVIDIA broadcast to remove the background, yada yada, so let me know how it goes. Most likely, I'm sure I will always be looking at code which is covered by my face, but hey, baby steps, right? Anyway, so the big update that happened in the engine in the past few weeks has been a completely overall redone material system, right? So let's have a look, and visually pretty much nothing changed except to a specific thing. And let's see. So here again, engine, you have the grass, and you kind of see my night kind of exploded, right? So, and this is basically the test case I was working with. Basically, I'm able also, among other things, with new material system, I'm able to have different matrices per object. Before, everything was rendered at the origin, right? So basically, an identity matrix, which of course can only get me so far. So this is one of the things. So I wanted to clean up all the material system, which was quite involved, and we're gonna go into that, and also have proper way to bind matrices in a generic way. There was some interesting discussion on Twitter, but basically this is more a test case, so each one is using a different matrix, and particularly in Vulkan, I'm using push constants to basically select which matrix to use, and in DX12 I'm using root constants, if correct, yes, I think it's root constants, right? Basically it's very similar, it's slightly different, but it's similar to fetch the matrix. And this was a huge pain because I decided to use GLSL all over the engine, right? So if I needed HLSL, I would cross compile with SPIR-V cross to HLSL. Other people told me like, careful, because like pretty much everybody uses HLSL for Vulkan as well. So if they need to use both, sorry, they cross compile to GLSL from HLSL. A lot of work is going into DXC. And my reasoning behind was like, I like mostly working on the Vulkan backend. So if I need to implement something, I want to implement it first in Vulkan, then I go to DX12, do the heavy lifting in Vulkan. So GLSL makes sense. Until I got to push constant, then basically you get to an ambiguity where cross-compiling to HLSL, I had no way from the metadata system that we're going to talk about to know, okay, is this a push constant, a root constant? Like, what is it? I had no way. That information was simply lost. Instead, going the other way around, you can annotate the HLSL code, and you know the difference. But let's go back to business, okay? So the goal was, first of all, I wanted a generic binding system. Before, I had a horrible switch statement, basically say, oh, this is forward PBR. Say, right? Okay, so the piece of code knew exactly, okay, this shader is gonna need this at this slot, this texture, these buffers, right? And of course it was horrible, but it's a good starting point, but at one point it needs to go, right? So I wanted a generic way. And also I wanted to start same, then translate to matrices, of course, because matrices is just a part of the data you need to do a draw call, but I want to deal with matrices in a more efficient way, slightly differently. So that was the main idea. And also I had hard-coded root signature, right? So I had a JSON file with the definition of a root signature or pipeline layout, if Vulkan term. And that allowed me to create my pipeline layout, etc. But I wanted to have a way to have all the information needed to bind my shaders, generate root signature from the shaders, and so on. So the first things I did was like, okay, I need to extract all this metadata from the shader, okay? So usually you use a sort of metadata library to extract this information from the shader. Either you roll your own, you do basically what a compiler does, parsing, but it's fairly fiddly, and I wasn't like super hyped about it, although I like compiler work and I've wrote a couple of toy compilers. I was not really into this, so I said, okay, let's use something good. So I decided to use SPIR-V cross. So basically you go to SPIR-V and you then extract all the information you want. Now, so this was before I moved to HLSL, but luckily I'm still using, even with HLSL, I just compile to SPIR-V, and my metadata still works. So when I did the transition, metadata-wise, nothing changed. Luckily, everything still works perfectly fine, and that's why I ended up using SPIR-V to do the reflection. Basically, that's what it takes. So let's have a quick look. The metadata, material metadata is pretty simple. I have basic structure to define binding slots, right? So basically you want to know that you have a texture of the specific slot, or that you have a buffer, or if you have say a constant buffer, and then especially with constant buffer you want to know what's in there. Okay, that's because it's gonna help you to populate that data if you want to, or if you just want to update part of the data. So for example, we can see here we have material metadata struct member. So if you have a struct, for every value in the struct, you have this information which tells you, okay, what's the name, what's the offset in the struct, what's the size, and then once you have that, you can do brute force mem copies around if you want to, right? So there is no big deal. And just a second, there we go. Similar for uniforms, then material resource, so you can, for example, okay, you have a resource in your material, in your shader, where is it visible? Is only fragment shader, compute, where is it visible? So you can set correctly your descriptor visibility as well. The set, the binding slot, the set, because I use specific binding slots. Let's actually open a shader really quick. So maybe the grass forward. So it's grass expansion, I think. There we go. Right, so ignore the IntelliSense is all broken, but basically, so you see here, I have semper state, I have a byte address buffer, which is bound as slot 1, space 3. So space 3 is where I put everything which is object related per object. Space 0 is per frame. Space 1 is the samplers. So you can see all the samplers are bound there. And then we have which is not here, space 2, which is basically per pass data. So say you're doing forward, in the pass data you have all your lights, all that kind of stuff. That's how I do it. Right, so I extract all this information, and I know basically what to do. So if I tell you at a high level, say, oh, bind albedo to this material, I know where to go. I know how to look up which bind slot it is. I know I can validate, hey, you're asking to bind a buffer to albedo, but it's a texture. So I can throw errors, I can do all these kind of things. So it gave me a generic way. I don't know how fast it is, but for now seems to be okay. And also, like, for how the engine is right now, you just basically bind stuff as startup, except few other things that are on the fly, but 90% of the bindings is static, right? So if you render a mesh, it's always the same thing. And that's also why matrices are handled externally with a push constant, so I don't have to update the bindings of the constant buffer, say, or these kind of things, because you need to buffer your matrices and all this fun stuff, right? So that's basically the idea. And the material deals with the material, where a material, it basically is backed by the pipeline states object, right? Pipeline layout, sorry, pipeline. So is a combination of all the shaders. So what I do is that when I process the pipeline, I generate the metadata for both shaders. Say you have a fragment and a vertex, and then I merge them. So I'm able to figure out, oh, okay, this buffer is bound, say the camera buffer or whatever, is bound both in vertex and fragment. I merge that data, right? So I remove basically the duplicate between the two, and I have a single set of data for the whole pipeline. Okay, and the code is not particularly fancy. So you see there is a lot of mapping. So for example, SPIR-V gives me a specific type. I need to map to my own type because I have my own metadata format which I store in binary, then I'm able to read up. But the main idea is that basically SPIR-V gives you structures. Let's see if I can find the actual entry point. Extract metadata from shader. There we go. So here is where I go to SPIR-V, and there we go. Then SPIR-V here, it gives you a series of resources. So for example, you say, okay, here are the images, separate images. So separate images are the one not combined with a sampler. Then you have your storage buffer, so the normal buffers where you store stuff. Then you have push constant buffers. I should still have the uniform somewhere. Here we go. So you have uniforms here. So basically you just go through all of the data and you extract the information you need. Boom, you dump to binary, you're good to go, right? So I do that at compile time of the PSO. So this data get generated once, then I just read it back up, so it's faster. So nothing particularly fancy, and then the material system uses that to route all the data. So that was the huge part of work, allow me to basically, of course I was actually looking exactly where I said I was not going to look at, sorry, so let me move it here. So this was a huge amount of work, because also allowed me to clean up so much of the engine. Like I literally removed so many thousand lines of code dealing with the crappy old material system. So this is much better. Why is there a regex here? It was for testing, I don't need that anymore. So there was a huge chunk of code. It's now much cleaner. So now the only JSON which are still are coded are the material itself, and we can actually have a look. I should have it here. So this is a material. So let's grab night, for example. So this is a material. We describe the material. So we say, okay, you have a texture which is bound to albedo text. So here is text-based. Nothing stops me to actually go to index, but unless it's a performance issue, so these things happen at startup, I'd rather keep the name, because I can map the name to an index and at least it's clear what is what. So then you have the tangents, roughness, so you have all the PBR data, okay? Then you have a mesh. The mesh doesn't have a binding name because I know how to handle the mesh. The mesh is always handled in a specific way. So the mesh always appear at the first entry of space 3 if there is one, and then all the other buffers follows. So that's why there is a single entry. So if you have points, normals, etc., then the material system is able to figure out, okay, you start from here and that's where your other stuff is. So I know how to bind all the different buffers. So you just give me a model, I'll take care of the rest. And then here is, for example, how you encode different uniforms, for example. So you have a constant buffer where I use, for example, texture information, where, for example, I call it texture configurations, where, for example, you can shift the UVs and scale the UV, right? So basically tiling and stretching of your textures. I set the name, I said what type is it, is a vec4, and the data of the vec4. So then, from this, I'm able to rebuild a complete buffer that then I can put on the GPU with the right data in the right place. Right, so this is where, oh, okay, albedo text config is a vec4, so it's this size and it's this offset. So I can simply do a mem copy. I get a vec4 and I do a mem copy of that vec4 where in memory it needs to go. Very, very basic, right? But seems to work. So this is one of the things that is hard-coded. This is going to change, because ideally you would generate this in an editor, right? So you start with a material, you start binding different texture. So all this is basically what is going to be generated by the editor. So in the future, I won't need to do that manually anymore, done by the editor. But at the end of the day, it's going to be the same thing. Whether or not I want to get rid of JSON and have a binary format, potentially if I see that it starts to slow down, it starts to be a problem at startup, which might be at one point, I can always convert to binary. And the last thing is the PSO. So we still have the PSO. So let's grab the cross forward, right? So this is all the information that I need to basically, the global root signature is actually legacy, it's not there anymore. So this is all the information that I need to build the pipeline state object. Okay, the pipeline needed for both DX12 and Vk. So there is the raster state, the format, all the kind of stuff. So I'm discussing with a lot of friends in the industry how to handle that. Some people like to be very strict with that. So you get a limited number of PSO and shader permutation, all that kind of stuff. Some people do a runtime, so basically a runtime based on what you ask. Say you don't pre-specify that you want this format of that, right? So you let the user sort of do what he wants, and then when it's time to do the draw call, is do, okay, you asked for this is the current state. So you said that you're gonna use this depth format, this render target format, this depth stencil, blah blah blah. That's the current state. Let me check if I have a pipeline test object which match that. Okay, if I do, boom, basically you do a hash, then you do a lookup, do I have it? Yes, I use it. Otherwise you generate on the fly. So generating PSO on the fly always, of course, is gonna give you stutter, is gonna be, but if you think of it, you're gonna only generate that once, right? So the first time you're gonna get the hit, fine, and nothing stops you in the actual build game to do a run through, keep track of the, basically build a cache of PSO you generate and dump that to disk, or at least dump enough information to rebuild that cache at startup. So there are ways to deal with it. I'm not sure which way I like it. So when I was working on SPIR-Metal, which was my metal editor, just a toy project for a bit, I actually did it with hashing in this way. It was not too bad. Not sure which way to go yet. I'll have a look. But so this was the big chunk of work has been done. The engine is much better. Now I think I'm gonna work on an editor, on a basic editor, just to have a slightly better workflow, because like giving this to someone else is painful, mostly for the resource side of things, because resources, the engine doesn't convert anything at runtime. So all the resources needs to be compiled. So for example, when you check the material here, you have this dot model. You don't have a dot obj. I don't read the obj because it's too slow. Everything is pre-compiled. I showed this before, but I have a resource compiler, right? Where so you get an obj that gets converted to my model data structure. Then you have texture, they get converted to BC1, BC4, BC7, whatever you need, and you load pre-compressed texture with the MIPS, animations also. It's all binary, so try to basically at runtime be to load it as fast as possible. No processing involved. You load the data from this and you set it on the GPU. That's it, no extra data. But that's really painful, because if the engine doesn't have the data it expects that you tell, say for example that dot model doesn't exist, I assert. I hard assert, so it's tough for somebody that is not used to this or it doesn't know what it needs. So if you just want to open a normal scene, say, oh, I want to render this sphere. Oh, you're gonna need the material, you're gonna need that. So it's not easy to work with, so I want to make it more user-friendly. That's why I might work on a bit of an editor. Basic, very basic, but just to deal with all that stuff. Let's see. I'll keep you posted as usual. If you want to know how it's going, subscribe, share the video, all the yada yada, and any question let me know. You can find me on YouTube, Twitter, all those places. So see you in the next video.